Eventually, we're going to want our robot to be able to drive down this corridor and come to a stop before it hits the wall. Um, and we're going to want this distance to be a very specific distance so that when our robot turns, it's pointed down the middle of this corridor. It's not a little too far to the left or a little too far to the right. And then it'll be able to go forward and go on its merry way. And the trick is, how do we figure out what distance this should be beforehand? Now, we could try and hard code a number in there, maybe make some measurements, put our mouse up close to the wall, and then put in, let's say the number's 37. We put that into our program, and that's, whenever the amount of reflected light is above 37, the robot comes to a stop. The problem with that approach is the robot would behave differently under different lighting conditions. A better approach would be to create a calibration program so that when the robot's at the beginning, before it even moves, it turns right. And then it measures this distance and stores that number. And then it turns back forward and starts its voyage through the maze. The first step in keeping our robot from crashing into a wall once it reaches the end of a corridor is to create a variable that's going to govern the distance from the wall where the robot's going to stop. I'm going to create an integer variable called targetFront. It has to be an integer because it needs to store values that range from 0 to 1023, the values generated by our IR emitters detectors. And then I'm calling it targetFront because we're also going to have some target side values. Once that variable is created, I'm going to scroll right below the loop and create another function called Calibrate. The Calibrate function is going to start off by turning the robot right, pointed straight at a wall. Once it's pointed at the wall, what we would like to do is set the target front value equal to what the sensor is seeing. The front sensor is seeing. Unfortunately, this value is not going to work yet because we haven't initialized the sensor. So we need to do that right before that line of code. And now this value will exist and be valid, and we can put it into the target front variable. Then I'm going to turn my robot so it's pointed back down the corridor. And I'm going to initialize the sensors again just because this is a calibration function. So you would expect that when it's completed, the robot is ready to drive down the hallway. And that's all we need in the calibration function. Once that's done, we're going to go right up to the end of the setup. And the next thing we're going to do is create a while loop, or we're going to call the calibrate function. And then we're going to create a while loop. We're going to say while the front sensor is less than the target for the front sensor, we're going to want to go forward. Now, it's worth pausing here to really understand this. While the front sensor, the amount of light we're registering as being reflected back into that front sensor, is less than the target front value, the amount of light we would expect to see from the wall, or that we're shooting to see from the wall when we get close to it, while that's less, we're going to go forward. Once it's greater than that, we're actually going to stop. So the forward stuff we actually already have. It's right here in the loop. It's right here in this loop. And what we're going to do is just cut it and paste it right into this while statement. I'm going to hit Control T just to get my white space cleaned up. And then I'm going to stop the robot. Motors dot stop. So this looks pretty good. I'm going to put another little bit of white space. This looks pretty good. There's one other thing I want to do, and that is right after I push this button, I'd like to give myself just a little bit of time to get my finger off the robot so that I don't affect it when it tries to turn right away. So I'm going to put a small delay in here of just half a second or 500 milliseconds. And that should be it. Here you can see our program in action with one slight problem. And that is that as the robot approaches the end of the corridor, it tries to equalize the amount of reflection it gets on both the left and the right, causing it to veer a little bit to the right at the very end. For testing purposes, out of the wall at the end of the maze, make sure your robot behaves as expected. We'll correct for the problem we saw in the previous clip in the next lecture.